In this guide, I'll try to give you the knowledge that I wish I had when I first started playing this. Hopefully it will be useful. Compared to Vulcan in Venus, our major problem is the heat. Despite the fact that its top temperature being lower than Vulcan because of the atmospheric pressure, the heat conducts way too quickly, which will tax our cooling systems much more compared to Vulcan. As soon as we start, I start raising my suit temperature and lowering my suit pressure. In order to cool your suit down, your suit pushes some extra oxygen from your air tank to your waste tank. This is the main problem we have to deal with on Venus. And because of this, I set my suit temperature to 50 degrees Celsius and my pressure down to 50 kilopascals. For some reason, our character can comfortably live within a 50 centigrade suit. Don't question it, video game logic. Point of lowering the pressure is that each time we open our visor, we're going to be wasting less oxygen. By the way, the suit temperature does not affect thirst. It doesn't make much sense, but whatever. Next, I rearrange my UI into a less painful setup. Devices that require batteries or canisters are at the top row and the rest at the bottom. And as soon as I get off the emergency lander, I start mining. We need 20 iron and 6 copper ASAP. When I start building my habitat, I take care to point my habitat entrance to heading 0. This will come in handy later on. The midday sun won't get inside and annoy me, and our solar and sensor setups will be affected by this. While setting up my arc furnace for the first time, unfortunately I misplace it and have to drill it out and replace it again. At this point I'm trying to keep things as small as possible, trying to save cable coils. We need 2 doors and 6 pipes at this stage. I start the active vent as soon as I place the pipes. Unless you set it to something else, active vents are limited at 50 megapascals. Now I remove the 2 pieces of pipe which will snake the air inside into the 1 piece at the outside, which will overpressurize it and blow it up. And that blown pipe piece will be our makeshift pipe cowl. Now we have our airlock ready. If your pipe in the outside has not blown up yet, you don't have to wait. You can use the air vent, push the air inside the airlock into the single pipe piece, and if you remove the pipe, you'll basically be deleting the air, which might save you some time. And of course, as soon as the pipe outside blows, you can connect the pipe and use it as you would with a regular vent or pipe cowl. And then I'm emptying my waste tank into the airlock I've created, then using the air vent to push it into the other separate pipe network that I did not blow up, which would be storing my air for some time. The fact that it's staying in the outside, it's going to be heating up slowly, but that won't be a problem. We won't be able to reuse our oxygen anyway. Since we set our suit temperature to 50 degrees, our waste tank temperature is way too high to be reused. To be able to reuse the oxygen there, we need to cool it down in the first place. Next, I set up the solar panels on the top of my habitat, and this way they won't be blocked by anything else. Don't forget the orientation of these solar panels are important, and there are 2 different solar panels. I'm using the single port one here, because I absolutely do not have the cables to spare. Then I point my solar panel towards the sun, but unfortunately I fail to realize that I did not connect it to my electrical network. Before the sun sets, I go mine some more iron, because we need to finish our habitat ASAP. If you load your air tank within your airlock, you will also prevent your air slowly heating up. Your medium canister protects your air supply from heating up on its own, but if you connect your air tank through the canister you've connected, your air source will start heating up over time. Now I start using flares to save on electrical power. Unfortunately, the red is kind of annoying, especially with the glow, but I do not have the batteries to use the headlights on my suit. If you place these light sources on your uniform, it does not create weird shadows, or at least less of those. At this stage, my only goal is to finish the habitat, vacuum the insides. So, only thing I'm mining right now is just iron, or frames and sheets. As soon as I complete and enclose my habitat, I start using my airlock vent to push the air out. And soon enough I get another waste tank warning, and of course I won't be able to wait until the entire habitat is vacuumed, so I just use my airlock once more. I like this type of airlock design because it leaves two surfaces empty for you to mount devices on, which will come in handy later on. And considering the fact that you have some time to waste each time you go through an airlock, it's the perfect time to change batteries, which is why I have a battery charger in the airlock, which can also be, of course, accessed both from the inside and the outside. And there's a power controller in there, so that if you get stuck in the airlock, you might be able to override the power control with a battery and keep it going, which is foreshadowing. Finally, my habitat is completely empty of any gases. That means no heat transfers in the inside. As long as we spend our time in our habitat, we won't be consuming too much oxygen. But of course, I cannot keep the arc furnace inside anymore, because it will create gases which I do not want. Plus, I cannot fill the habitat with any kind of air or oxygen at this point, because of our heat transfer. Even though we have a completely encapsulated windowless habitat, because of our pipes, doors, etc., we will be slowly leaking heat through our enclosure. Considering the fact that we do not have any cooling capacity right now, we cannot afford to fill our habitat with any kind of air. At this point, my mornings are basically setting up the solar panel to look at the sun, go mining the needed materials, and at night take care of the habitat and build new stuff. While mining on Venus, one problem you will constantly face is because of the atmospheric pressure here. The air currents are way too strong. They can easily drag you around, slam you into walls, and break your suit. You can get away with doing it once, but as soon as the air starts leaking into your broken suit, even if you patch up, your lungs will be burnt. You might be able to fix that once with the single pill the game gives you at the beginning, but unfortunately if you do it a second time, they'll most likely kill you. So in order to prevent that, first of all, do not mine while your jetpack is on. Try to mine horizontally, and try to stay as far away from your target as possible. Mining while not moving forward also helps. The idea is your friction on the ground can counteract this air current if you are far away enough. Your jetpack, even at the maximum thrust setting, isn't strong enough to be able to withstand these air currents. Each time I return from mining to empty my waste, I point my solar panel towards the sun once more. Now I am placing frames in the inside of the habitat, which will allow me to stack my fabricators on top of each other. Moving my arc furnace into a different spot, so I can use chutes to move the produce inside the habitat each time something finishes smelting. If we were to consume our starting food and water at the same rate, you will run out of water much earlier than you would run out of food. Which is why I'm filling up my belly to 100%, but trading health for thirst. I let my health get down until like 25% or so, and then sip a certain amount of water, about like 60%, which will heal me up back again. At this point, I'm eating and drinking within the airlock, because the minuscule amount of gas we release each time we open our visor is a pain in the ass to vacuum out of the entire habitat. Much easier to vacuum out of the airlock, which is just a tiny room. Setting up the solar panel in the morning again, and going mining. Now here I finally realized that my air vent is not able to drain the entire airlock, because I forgot to add more pipes in the inside, which is already filled to the brim with my waste gas so far. Once I'm done, I remove the iron frames, because despite this game being very detailed in chemicals, heat transfers, and energy, it has nothing on physics. As soon as I weld up my fabricators, I vacuum the welding byproducts out of the habitat once more. At this stage, I replace my battery charger with the larger one. I paint two different pieces of wire in the airlock, white and yellow, which I will use as a sample later on. And don't forget you can paint your flares to whichever color you want. You can use the new flare gun to be able to relight spent flares, but I did not want to use such an exploit in this playthrough.
Power low. Pressure critical. Oxygen critical. Low pressure.
Now my next goal is to set up an automated solar panel system, so I don't have to mess with it every single day. Don't forget the orientation of your sensors, and your solar panels absolutely matter. You will need one solar sensor, one chip to read the sun's horizontal position, one chip to write the horizontal position back to the solar panel, and similarly for vertical, one chip to read it, one chip for math for an adding operation, one memory chip to store how much we want to add, which is 90 in our case, and one chip to finally write the vertical result back on our solar panel. 6 chips total. This is a complete solution, but also if you don't have enough materials at this point, you might be able to get away just by setting up your solar panel at 45 degrees or something, which will cover the entire day. Not perfectly, but would be good enough. And at this point, I completely forget that I have left the air vent leading inside open, and I start contemplating my life's decisions. As soon as I realize I bet I've mixed Venus atmosphere with the waste gas that I was collecting. I'm using batch writers at this point because I'm going to be adding more solar panels.
Airtime critical.
Now I start preparing a hot room for my makeshift furnace setup, placing an unloader, which is basically a stacker, for my furnace input. The point of doing this is that I do not like either the chute inlets or the powered inlets. On one, the chute inlets, you have to throw your stuff into it, you cannot just put it in, like as you would a fabricator inlet. And on the other one, you have to connect power, but also you have to flick a lever each time you have to send items down. I don't like either of those. With this unloader, it behaves exactly like a regular inlet, as you would with any fabricator machine or if you were to use the furnace's own inlet. You can basically either throw things into it or put it in, and you don't have to mess with a lever each time, which is why I use this. I am connecting my single pipe to the furnace's output, not its input. The point here is that this regular gas furnace has a one-way valve that you cannot control at its inlet. This regular gas furnace on its input port has a one-way valve, which you cannot control, and because of that, it causes you to waste fuel every single time you want to empty the furnace. But if you use its output port instead, the pipes you connect will become the furnace itself. In order to not increase its internal volume by so much, I'm trying to keep the amount of pipes down to a minimum. At this point, my furnace's internal volume is limited by the furnace, the pipes that are connected to it, up until the valve. I'll be using this passive vent and valve to send Venus's atmosphere inside the furnace so that I can melt the stuff that I put in there without using any fuel or any energy on my part. Now, this furnace will be in a hot room, which I will cover with a glass. But the thing is, when the gas inside heats up, the pressure will increase. And unless I want it to blow up and lose all the heat inside and forcing me to replace the glass each time, I need to have some kind of pressure relief at the side. This is easy for Venus because the planet is already 238 kilopascals, and for a hot room we only need about 100 kilopascals anyway. So in this case, just 2 vents and a one-way valve will do the job. Those iron frames making up my hot room can withstand up to, I think, 2000 kilopascals of pressure difference. But the glass I'll be placing in the front will only handle about 200. At the point of having a hot room, which in previous versions you did not have to do this, furnaces now radiate heat, despite not conducting any in vacuum. We have to keep our furnace in about 100 kilopascals, and with hot air in order to prevent both radiating and conducting heat, and therefore our furnace will stay at the temperature we set it to for much longer. At this point I'm trying to set up a cheapskate jetpack refiller device, which is just repressurizing the atmosphere inside a canister. It's unrealistic perhaps, but this game does not require any kind of burnable propellant. It just needs to be high pressure. Any type of gas will do. So it's pressurized atmosphere it is, because we're the cheapskate. On the other hand, don't forget that your starting nitrogen canister is also a cool gas that you can use to pressurize your habitat later on, so it is also a precious resource. You can use the Venus's atmosphere to melt gold and copper and also turn them into ingots. You can basically melt anything using the atmosphere, but the problem is melting them is not enough to turn them into ingots. For example, you can melt iron, but as soon as it's done melting, all the furnace will give back to you is just lumps of iron once more. But for copper and gold, you can melt and turn them into ingots just by using the atmosphere. Which is great because melting gold, especially, requires a ridiculous amount of energy using the arc furnace. Setting up my hot room pressure release. I didn't have another air vent at that point, but only thing that goes outside is just an air vent. Now another way to input gas into the furnace with a back pressure regulator. The point of using a back pressure regulator is it uses less power and it's slower, which I require here. I'm filling my canisters to 9000 kilopascals. The simplest iron canisters, I think they can withstand 10,000 something kilopascals, which are good enough. You don't need to worry about temperature too much unless you leave your canisters on the shelves or lying around on the ground, because when it's in your suit, they are all just protected against any kind of heat transfer. Finishing the chute connections of the furnace. Connecting 3 pipe heaters. Every single one of these, when they are running, they require 1000 watts. And our simple cables that we have been using so far can carry only 5000 before blowing up. I'm setting all my pipe heaters to on for now, because I'll be controlling them from the outside with a transformer. I'm placing a single inward-facing iron window, which encapsulates the furnace inside the room, but also gives us access to the furnace's controls from the outside. I'm going to place a shelf on the outside, just for ease of use, and remove the window for now, just because I'd like to use the furnace to melt my lumps of ores for the time being, and I would like the atmosphere to quickly equalize with it. Next, I try to set up my furnace in such a way so I can finally make lead alloy, but unfortunately I forget my valve open. Now heating up my furnace by pumping my jetpack air, which is just pressurized Venus air, into my furnace.
Power low.
At this point I'm using a portable light on my jumpsuit. Its light is much less harsh compared to flare and much softer compared to our headlight. But keep that in mind that your headlight still has a longer range. I have melted 3 stacks of iron and 1 stack of coal using the Venus's atmosphere, but of course I cannot get steel with that. So after the furnace equalizes with the pressure heating up again, I'm going to get it the rest of the way using my welder's fuel canister. You don't need to click the furnace igniter more than once, but I just like doing it. And of course, I forget the valve open again, unfortunately wasting my welder fuel, which is extremely precious in this difficulty and on this planet. Because unless you manage to set up a trading port, you won't be able to get more of it. And to be able to set the trading port in the first place, you need to be able to have some fuel to be able to weld the steel and stuff.
Jetpack critical.
Despite being less than ideal, I managed to get the steel out without wasting too much fuel. Of course, just after the steel, you can very easily make some Electrum right after that. Of course, I use the opportunity to do so. And when I'm done, I let the furnace equalize with the Venus atmosphere once more. As soon as we have steel, Electrum, and solder, we can print ourselves a pneumatic mining drill, which is much faster compared to our previous electric one. If you pick up one piece of painted item, which is a cable in this case, and then add a stack on top of it, the entire thing will be painted. I don't know how that works, but at least it allows you to save some paint. I'm using pressurized atmosphere, the same one I was using for my propellant, on my pneumatic drill. Here's another advantage of filling your regular canisters to the brim, is that pneumatic drill performs better with more pressure. I will be marking my power generation line with the yellow cables. My secondary line after my station battery will be white, and everything else will be red. As you can see, pneumatic drill is quite fast compared to the electric one. During the storms, your solar panels will get damaged. Instead of bothering to repair them, which takes a ridiculous amount of time, you can remove them and replace them as soon as the storm subsides.
Health low.
At this point, I have moved all of my oxygen in my portable tank into my Habitat's canister filler, so that I can fill my canisters to the pressure I'd like, which is 9,000 kilopascals. While trying to call for traders, we're going to be fiddling with the satellite dish and the computer all the time, and that is going to be taking quite a lot of time. If we had to try to do this outside, we were going to be wasting oxygen just to be able to cool our suit down, so instead we'll just place it inside. How does an antenna work in a steel Faraday cage? I have no clue, but it works, so whatever. Now I'm preparing my control panel for my atmospheric devices that I'll be mounting on the outside of my habitat. Nothing complicated, it's just turn on and off, that's it. I have placed 3 more active vents to help the exterior vent that I was using, so it can be 3 times faster going inside the habitat. These extra vents will only be powered by my station battery, so unless we have extra power, they will not be used. On the back side of the habitat outside, I'll be placing my atmospherics to cool my habitat down. Just a single line of 7 atmospherics. I'm using iron frames again to be able to mount my atmospheric devices in the air. This will come in handy later on. And to the side of my habitat, I'm mounting my filtration units. One to add coolant to my cooling system, filtering out nitrogen from the atmosphere and into my cooling loop. Another to separate oxygen from my habitat's internal atmosphere and push it into my oxygen storage. Then one more to filter hot carbon dioxide from the Venus atmosphere and into my habitat. And one last one to filter out any unwanted gases, mainly pollutants, and just because I'm obsessed, nitrogen as well, from inside of my habitat and release it outside to Venus atmosphere. By this point, I have set up a station battery with a transformer limited at 5 kilowatts to protect any wires in my networks. If I don't use any kind of batteries below this transformer in the hierarchy, I don't need to use any other transformers or fuses, because my entire electrical network will be current limited and nothing will blow up. Each air conditioner is looped around itself, recirculating the same gases. Mounting air conditioners in the air like this allows you to loop them with as few pipes as possible. And each air conditioner dumps the excess heat and its waste into the next one. I'm now using a one-way valve for my nitrogen filtration unit to be able to fill my cooling loops. The reason I'm doing a permanent connection like this is because if you increase the amount of nitrogen in your cooling system, you will essentially be making a heat battery. Of course, I'm not going to be filling it to the brim just yet, because frankly, I don't have the energy to spare yet, and cooling too much gas will take a very long time, which is exactly what I don't have right now. But keep in mind that you also need to have enough gas, which is about 1 megapascal per air conditioner. Otherwise, each heating loop will be too whimsical and the air conditioner will overcool and start heating, and then do this over and over, wasting what little power you have at this point. Now I'm setting up my helper vents, reading the exterior vent in my airlock, and copying its on status and mirroring its status to the others. Therefore, if one is active, the others will turn on as well. I add a button inside the habitat to be able to dismiss traders from the inside. Because for some reason you can call traders to your landing pad from your computer, but you can't tell them to go away, and you just tell them face to face. I don't like doing that. This isn't exactly the best way to cool your base, but we're constrained on resources right now, and this is the best cheapskate solution I can come up with. At this point I have 7 air conditioners, assuming the Venus atmosphere at 470 centigrade. Each of them cools about 90 degrees, and the final one gets the nitrogen in its pipes down to minus 80 degrees. And the very last 7th air conditioner uses that minus 80 degree nitrogen to cool the inside of the habitat to 20 degrees. The first 6 are basically making my coolant gas, and the last one cools my habitat. For the time being, my habitat is just consisting of the pipe that I have collected my waste oxygen. The very last air conditioner just dumps its heat directly to Venus atmosphere. Using a vent like this might not work in other planets, for example in Vulcan. You cannot use a method like this because the atmospheric pressure is too low. Now I am setting up the remotes for outside atmospheric units. Finally, I'm adding a drain to the cooling loop of the last air conditioner that is going to cool the inside of my habitat. If any kind of gas ends up liquefying there, it is just going to be drained outside instead of potentially damaging or breaking my pipes. As you can see, my earlier mistake, which mixed Venus atmosphere with my waste oxygen, including pollutants, is now just draining outside. The rest of the carbon dioxide and nitrogen is harmless anyway. Now I'm setting up a grow light farm in the inside of my habitat. You can use 30 hydroponic trays under a grow light in a rectangle shape. One large structure block is 5 by 5 small blocks. Therefore, you can use the center block of your habitat to count to 25 and then add 5 more. Now I am finally converting my airlock into an automatic one. You have to use your composite doors because the regular glass doors will not withstand the pressure from Venus atmosphere. I'm setting my satellite dish to maximum power. There's pretty much no reason at all to ever use lower power settings. And I'm setting it to vertically 45 degrees, hoping to cover as much as possible. Now I have a bright idea. Since anything you smelt creates gases, and coal smelts instantly, I can fill my habitat very quickly with moderately cool coal gas if I use an arc furnace inside. Well, 200 degrees is much better than 470. The problem is, now I have lots of pollutant in my habitat. 5% is way too much, both for plants and for breathing. Filtering it out with an air filter will take way too long, so I'll have to come up with an interesting solution. While we're at it, I start prettifying my habitat and place a pipe radiator on my oxygen supply, so whatever air conditioning applied to my habitat will also apply to my oxygen supply. 4 air vents is much faster. I finally decide to pressurize all of the air in my habitat in pipes again, so the cool gas will turn the pollutants into liquid and squirt it outside with the drain I placed earlier. So of course all the air inside my habitat does not fit into the pipe network I made, and I end up having to open my visor in my contaminated habitat. Of course, as soon as you do this, unless you want to damage your lungs and end up having to use the single pill that you're given, you need to flush your suit immediately after. So I get another bright idea, adding some random pipes to increase the pipe network size, so finally all the air can fit in. Thankfully, it works and I managed to get rid of all the air into the pipes, draining out all the pollutants and putting it back into the habitat again. Then I add a pipe meter, my oxygen supply. For the next batch of steel, now I don't have an emergency anymore, so I can use my electrical supply and dump whatever energy I have into the furnace to get my furnace up to 1 megapascals and 900 Kelvin. I just barely managed to do it as soon as my power runs out. But because I did things in bulk, 700 grams of steel isn't going to run out anytime soon. Now I have a fridge inside, preparing for my first harvest. Adding more solar panels. I can fit a total of 10 solar panels at the top of the habitat, and best case scenario they're making about 4098 watts. That's lower than 5000, therefore I do not need a transformer to save anything underneath that circuit. Now setting up my landing pad just to the side of my habitat. Don't forget that the arrows in the landing pad center indicates where the spaceship will approach from. If you set it to the wrong side, they'll hit the top of your habitat and maybe crash and break a couple of things. Of course, you have to have the landing pad data and power to the side. And I am setting up 2 liquid outputs and 2 gas outputs. The second ones are just for good measure. If I ever have to empty the gas stored in the landing pad, I'll just use these ones to dump it into the atmosphere. And the other one, the liquid one, is for water and the other is for oxygen. For some reason, vending machines need to be on the outside. It cannot be in your habitat. Despite being on the same network, it will not work that way. Setting up more logic, one for the landing pad clearing button I've set up earlier, and the other for the grow light. For the button, you just need a single writer. As soon as the button is pressed, it will send signal 1, and the writer will write that exactly to the activate button on the landing pad data, therefore getting rid of the trader who has landed there. For the grow light, you need to read the sun's angle with a logic reader, compare it with a compare unit to a memory cell, which holds 112, and then if sun's vertical angle less than 112 degrees, it is going to turn on my grow light, or off, it's the other way around. I'm using a batch writer here, so there's less items on the list, which I have to cycle through just to get to the grow light. And that's all the logic we need. The explanation of this solution is in Stationeers wiki, you can take a look at it. The air conditioners operate best at the room temperature. Too cold or too hot will reduce their temperature differential efficiency. So you might want to mess with their temperature differentials between each other, instead of just equally distributing it as 90 degrees. But for the time being, it'll work just fine for our purposes. By the way, the reason I have selected nitrogen for cooling in Venus is because it's present in the atmosphere first of all, but it also can cool down to minus 80 degrees and be pressurized into any pressure and still remain a gas. It will not condensate, unlike carbon dioxide, for example. The next best is volatiles with a minus 70. You can check the Stationpedia for phase change graphs. And let me remind you that the Stationpedia and Stationeers wiki are different places. The Stationpedia is in-game one, and Stationeers wiki is a wiki site on the interwebs. At this point, I'm using the knights in my habitat to communicate with traders and call them down no matter what they have. The reason you would want to call down whichever trader you find is because that these traders are only hanging out in your planet's orbit for 30 minutes. Unfortunately, you will not be standing in front of the computer all that time, so you might miss the sweet spot. So instead you call them down, keep them on planet, and when their 30 minutes are up, they will keep staying on your planet until you decide to let them go. And in 30 seconds, a new trader will show up, and you will once again have fresh 30 minutes, call them down. And now I realize the situation I have put myself in. Health critical, thirst critical, hunger almost critical, and I'm in a store. Great. At least I managed to make it back. Thankfully, my airlock makes quick work out of Venus atmosphere, letting me inside. And at this point, I have my farm already going with my first 3 potato plants. And since the habitat air inside is already cooled and filtered, I'm just dumping my waste gas inside the habitat. Keep in mind that I am not using my waste gas to dump oxygen outside, which would fill my waste tank with Venus atmosphere. It's only just oxygen and carbon dioxide in my waste, nothing else. And of course, because of the storm, I have to remove and replace my solar panels once more. And of course, the trader I have called down has nothing useful at all. My cooling system has drained all my batteries, and so I override my airlock with a battery on hand and get inside. Because my station batteries is empty at this point, my HAL prevents aren't helping, and it's taking a ridiculously long amount of time just to be able to get in my habitat. I was spoiled by the speed last time. Of course, next I replace my solar panels after the storm is over. And while my cooling system is on, which is draining batteries in seconds, I decide that it's a good idea to just connect a small battery and attempt to cycle my airlock. Whoops. And guess what? All of my batteries are empty, none of my tools have any batteries with any juice in them, and I'm completely stuck. My waste tank is filling up, I'm still exposed to Venus air, I don't want to go outside or inside, considering the cool air inside my habitat is precious to me by this point. Looking at my charger and batteries in there for a last-ditch effort. And of course, the single battery I connect just depletes in an instant. Finally, I get a bright idea to use my final life support battery to be able to finally cycle my airlock. Hopefully that will teach me not to do that again, and turn off my cooling system at night. At this point, I'm filling my habitat with Venus carbon dioxide very slowly by using the filtrations outside, which raises the habitat temperature up to like 40 degrees and then stop it, cool it down, add some more, and repeat. The reason I do not want to go up to 100 kilopascals is that 60 kilopascals is about enough both for your breeding and plants. Also, having less air makes for a faster airlock. At this point, I have already set up a microwave, because eating raw potatoes can only satisfy a very small amount of hunger, while cooked ones are multiple times that. Since the depleted and useless items from the beginning of the game has been piling up, I decide to set up a recycler and a centrifuge. I have replaced all my tool batteries with large batteries at this point, so I'm getting rid of small ones. If I put just the space back in the recycler, I would have lost the materials of its contents, so I'm just doing this one by one. The good part of having corners open in your habitat like this is that you can pass wires, pipes, and chutes at the corners without messing with the insides of your habitat, so you don't lose the air inside. I'm connecting these pumps directly to my oxygen and water supply. While my potato plants are seeding, you can harvest half of the product. If you harvest both potatoes at once, the plant will be removed, but I'm just taking half the produce and replanting them next to the others. And since the other 3 pumps have been making noises and annoying me, I finally slap a single piece of pipe there so they'll shut up. So now let's prettify our space hut. You can hide the atmospherics around your habitat under these claddings. Claddings are not airtight, so they will not change how your atmospherics function. And finally, I managed to find a useful trader selling water. I kinda got lucky here. In most of my games, they arrive much later in game. So apparently, this time around, trading thirst for health was not necessary. For some reason, Stationeers deposits your gases in the landing pad, so before your trading attempt, you have to turn off the output pump and buy in small quantities. Otherwise, you risk blowing up the center of your landing pad and losing all the gas and liquid inside. I'm setting up a chute inlet to the side of the vending machine so I can put items into it. And at this point we have essentially doubled our water supply. We can turn off the pump now. Let's do a final flyby around our cheapskate habitat. I would have covered the top side with cladding as well, but the problem is you cannot mount solar panels on cladding, and removing them and replacing them during and after storms would have been much more painful that way. This habitat can sustain you for a very long time to come, and hopefully let you build a better base. I hope this guide helped you. Thanks for watching.